Hi everyone, it's Mr. H here, and in this video we're going to look at why the KRAI method works. If you haven't already seen the video about the KRAI method and how to use it, check that out in the first link in the description below. Assuming you've seen that, let's get right into it. The first example that we looked at was 2x minus 5 equals 7. And what we're really doing here to isolate a variable is we're doing BEDMAS in reverse. Now you probably remember BEDMAS. I'm just going to list what that is quickly here. BEDMAS stands for brackets, exponents, division, multiplication, addition, and subtraction. And so that applies if we have all the numbers on one side and we're trying to solve for a variable that's already isolated. So there you go, BEDMAS. And so an example of something like that might be 3 times 3 plus 4 squared minus 5. And so how you would solve that is you would say, well, I have to do the brackets first, so I have to do inside first, so that's 7, which would be squared minus 5. And then you'd have to do the exponents. So we've done the brackets, now you have to do the exponents. So the 7 squared is 49. And then you have to do, there's no division, so you'd have to do the multiplication next. So to do the multiplication next, you would get 3 times 49. Now, the way I do that is I think 3 times 50 is 150, and then it's 3 less than that. So it's 147. So if I can make it to a nice round number first and just take a little bit away, it makes it easier. So then I have to subtract 5. There's no addition, so I have to move on to subtraction. So this would be 142. So this is all well and good when all the numbers are together, but what about when the numbers are interspersed between an equation like we see on the left? Well, what we have to do to get the x by itself is we have to undo what BEDMAS does to the equation. And if we're going to undo what it does, we're actually going to do SAMDEB. We're going to do BEDMAS in reverse. Now hopefully it's clear to you that what the example I gave on the right has nothing to do with this equation on the left. So let's tackle that one. So undoing what it did. The first thing we did is we added 5 to both sides. So let's just look at that. We got 2x equals 7 plus 5. And then we said, okay, we're going to divide by 2. Now you'll notice here I've kept it written as 7 plus 5 in the numerator divided by 2. And that's important for a couple of reasons. The main reason here is that anytime you have something in a fraction in the numerator or denominator, and there's some mathematical operation between them, it's like there's brackets around those things. You have to do the entire numerator here before you divide by 2. Well, how does this apply? If you look at what the steps are here, x is isolated. And so we'd apply BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. The first thing we would do is we would do the brackets. All right, that would be the first thing. Then we would divide. Okay, so we have to do the 7 plus 5 and then divide by 2. That's how BEDMAS applies. Well, how does SAMDEB apply? How did we undo it using SAMDEB? We undid it using SAMDEB because the first thing we did is we did the subtraction or addition. We did this plus 5, and then we divided by 2. And so we added 5, and because we added 5 in the way we did, it's like that's in brackets. And so that step has to be done before we divided by 2. So by using KRAI, the last 2 steps of KRAI, we got all the like terms together by adding, and then we isolated the variable by dividing. So we did SAMDEB. So that's just the first example. The other 2 get more of the steps of SAMDEB. So let's look at the next example. So here's the second example that we did. Now remember that anything that's in the numerator like that, it's like there's brackets around it. And so we've got 3x minus 4 over 5 equals 7. And so what we're going to do is we're going to apply BEDMAS, but we're going to do that after we've first done SAMDEB. So let's see by undoing the steps if we can then see how BEDMAS applies. So SAMDEB, remember, is the order of operations in reverse, and BEDMAS is the order of operations then carried out. So let's see how that applies. SAMDEB. The first thing we're going to do is we are going to multiply because these are in brackets. So we're going to multiply both sides by 5. So 5 times this side, and then whatever I do to one side, I have to do the other. So 5 times both sides. So I've got 3x minus 4, and now 5 over 5 cancels out. So I'm going to get 7 times 5, which is, I'm going to keep as 7 times 5. So now the next thing I'm trying to do is, because this 3x minus 4 is in brackets, I can keep them written like that, I'm going to move into the brackets, and I'm going to apply SAMDEB inside the brackets with that. So the first thing I'm going to do in the brackets is I'm going to try to subtract or add. Now here I can add. So I can add 4 to both sides. So 3x minus 4, I'm going to add 4, so 7 times 5, and then that step is already done, so I'm going to keep that in brackets because that was a step I had to previously do. If I add 4 to both sides, that cancels off the right side, and I'm left with 3x equals 7 times 5 plus 4, 7 times 5 plus 4, divided by, we're going to divide both sides by 3. We're going to divide both sides by 3 because I have to isolate the variable, get x by itself. So now what I've done inside those 3x minus 4 brackets is I've divided. So I started by multiplying by the 5, then I went inside the brackets, and I added and divided. So now that we have x isolated, x is equal to 7 times 5 plus 4 divided by 3, let's see how now BEDMAS would apply in the proper order of operations, now that we've undone everything. Now you might wonder here, because the first thing we get is brackets. So 7 times 5 is brackets. Well, that's all well and good. But then it seems that we add before we divide by 3, which doesn't add up, right? Because we should divide before we add. But remember, anytime you have something in its entirety in the numerator or denominator, it's like that itself is in brackets. So what we're doing is we're doing the first set of brackets, the inside set of brackets, the 7 times 5. Then we're doing the outside set of brackets. And now that I've done both of those sets of brackets, now I'm dividing by 3. And so the order of operations applies here. BEDMAS applies properly. And so that's how that one would work, and that's why it works using the reverse order of operations. Let's look at the last example. All right, so this one applied all the parts of KRAI. We had to kill the fraction, we had to do the rainbow, we had to get all the like terms together and isolate the variable. And so let's just go through, again with SAMDEB here, and see the steps that are being carried out. So the first thing we did is we found the lowest common multiple of 5 and 3. And we found that that lowest common multiple was 15. So we multiplied both sides by 15. So what we've done here is we've multiplied. That's the first thing that we've done. And so then we said 15 over 5 is like 3. So that kills the fraction. And then on the other side we have 15 over 3. We said that is 5. So what we've done so far is we've killed the fraction, and now we're going to move on to applying the rainbow. The rainbow is just applying the multiplication again. So we're going 3 times 2 is 6. So 6 times 3x plus 4. Now 5 times 6 is 30. It's 2x minus 1. And so we've multiplied that, and remember we don't multiply 3 times 2 and 3 times 3. Otherwise we'd be multiplying by 3 twice, not just once. So we now have to apply multiplication yet again because the 6 needs to be multiplied in. So this gives me 6 times 3x is 18x plus 24. And then 30 times 2x is 60x. And 30 times negative 1 is minus 30. So we've had to apply the multiplication step really 3 times now. Now, because these were brackets that we multiplied into, now we're on the step with brackets. The brackets are gone now. We don't need them written anymore, but really it's like we have brackets around those steps. So I've just erased them again so we don't get confused by them. They're not needed anymore. But that is the part that's inside the brackets. So now that we're inside the brackets, we look in there and we say, okay, in the brackets there is also SAMDEB being applied. And so we say, well, what's the first thing I'm going to do? Well, the first thing I'm going to do is subtract and add. So what I'm going to do here is I'm going to subtract 18x from both sides. That's going to cancel off the left side. And I'm going to add 30 to both sides. That's going to cancel off the right side. And so what I'm left with is 42x is equal to 54, which is great. We've applied subtracting and adding. The last thing now to do is the multiplication and division step. If we divide both sides by 42, I end up getting 54 over 42, which simplifies to 27 over 21. So what we did was we applied SAMDEB. We had to multiply 3 times, and then we worked in these brackets, and we applied SAMDEB within the brackets, and we got our final result. The point is not to remember to do SAMDEB, but just to know why this works. You might find it helpful to do SAMDEB every time, but I think for most students, they find it more helpful to do the KRAI method in those 4 steps that are listed. So last thing, don't forget to subscribe. Hit that bell for new videos that are coming out. And then if you want to see the original video on how to use the KRAI method, that's on the left. On the right is a video about how to check your answers so that when you walk out of a test on solving equations, you can be confident that you got everything right.